Hi, this is the one of the first videos I'm going to do about probability. Probability is one of those topics that could be either really, really easy or really, really hard. Even if it's the easy stuff we're talking about, it gets kind of confusing as you go through trying to figure it out. So I'm going to try to be as detailed as possible. So let's start off with, probability. What is it? Classical probability uses, the flip of a coin, the roll of a die. If you have two of them, it's called a dice. And then I have this funny die down here, which has 12 sides. So when you talk about flipping a coin, you have, two choices. It could fall on a head, or actually face up on a head, or the face up could be a tail. So those become the possibilities of flipping a coin. If you're rolling a single die, then you have a possibility of rolling one of 6 numbers. And if you're rolling this fancy die, you're going to be rolling numbers 1 through 12. So these would be considered, what is possible when you do these, and I like calling them experiments. So let's get into some terminology. Some terminology of probability is outcomes and events. And if you can separate what the outcomes are and within the outcomes which ones you want to talk about, the events, then the formula for probability is not really that hard. It's the number of events over the number of outcomes. So let's be a little bit more precise about what each of these are. Outcomes are all the possibilities probably spelling that wrong, of an experiment. So what we're talking about here, all the possibilities, there's probably 2 S's in there. Oh well. We're talking about the possibilities of flipping of a coin are a head and a tail. The rolling of a die is landing on a number 1 through 6, and the rolling of this weird die is rolling on a number 1 through 12. So those would be all the possibilities. So these are the outcomes of each one of these experiments. The event is the outcome we are looking for. If you are flipping a coin to decide who's going to drive, what you're looking for is the head, so the other person drives, and what they're looking for is the tail, so that you drive. So even though there's an outcome of a head or a tail, flipping a coin, you're expecting one or the other to determine which way you're going to go. If you're rolling a die and you're looking for when does it flip an even number, your event then becomes a 2, a 4, and a 6. If you're looking for an event where the number is less than 5, you're playing a board game and you don't want to land on the 5th space, then you want it to land on a 4, a 3, a 2, and a 1, and that would become your event out of the total outcomes. Alright, so when we're using this formula, number of events divided by the number of outcomes, let me move that up a little bit, we can kind of take that die one and say, well, I want to know what the probability of rolling less than a 5. So when we're talking about this, it would become the probability of the event I'm interested in, rolling less than a 5. The total number of events. The total number of events would be the 1 through 4, so there's 4 of them. The total number of outcomes of rolling a single die would be 6. So this would equal 2/3. Now sometimes probabilities, the fractions get a little messy, so sometimes it's better to write it as a percent. And if you do 2 divided by 3 and multiply by 100, you're going to get 66.7%. So you have a 66.7% chance of actually rolling a number less than a 5. Now this is on a standard die. If it was on the other die, that fancy 12-sided one, then we have to take into account that sure, we want to still roll less than a 5, so the probability of this event gets adjusted only because of the outcomes. So there are still 4 numbers less than 5 on a 12-sided dice, but now there's 12 sides, so that would be 4 out of 12. So this would equal 1/3 of the time, or only 33.3% of the time would you roll less than a 4. So this is how easy probabilities can come. Now this whole set here, these examples that I've shown, are one flavor of probability. That flavor is called theoretical. We look at all the possibilities theoretically and figure out the probability. There is another branch of probability, and the other type of probability is called empirical. Now empirical, you actually perform or the experiment, or collect data. That's another way of doing this. The other part of probability is what's called empirical probability, and it's really easy to get confused between theoretical and empirical. But empirical, you actually do the experiments, like for instance flipping a coin. And of course there's only 2 options for flipping a coin. It's either going to be heads, or it's going to be tails. So if we do this experiment by flipping a coin, I would set up a little table, record when something landed on a head and record when something landed on a tail. Just flipping one coin here. So I found a neat little website that actually allows you to flip coins at random. So down here I've picked one coin, the same one that I'm looking at, and over here is a button to say flip. So I'm going to flip it, and what it lands on, I'm going to record it. So this is a head. Maybe I should just count up how many times this happens, because then otherwise I'll have to go back and forth. So flip again. That's another head, so that's 2 heads. Flip again. That's 1 tail. So far we have 2 heads. I'll do it on a piece of paper here. And 1 tail. Alright, if we flip again, we got another tail. And the way I know that it is changing is it has a timestamp over here. So as that number changes, I know I'm definitely flipping it. So if I hit it again, it's another tail. If I hit it again, it's a head. If I hit it again, it's a tail. If I hit it again, it's a head. Seems to be back and forth right now. Hit it again, tail. Hit it again, tail. And so forth and so on. So I'm just going to do this a couple times, come up with a number eventually. Tail. Head. Tail. This one's coming up too perfect. I did this before and it was like crazy tails. Ah, there we go. And a head. So let's see, that's 15, 16, 17, 18, 19, one more. And there's a tail. Alright, so what I got out of this, and you could probably rewind and figure out if I did this right, I found that there were 8 heads and 12 tails. So by empirical probability, the probability of flipping a head, where theoretically it should be a half, if we do the number of events over the number of outcomes, we're going to get, the events would be the heads that showed up, and the outcomes would be the sum of the 2 numbers, either heads or tails. So that'd be 18 or 8 plus 12. So the probability of landing on a head, empirically, is turning out to be, let's see, 4 goes into both of those, 2 out of 5. It leans a lot towards tails, so our probability of getting a head is less than a half. Now, if this number was 2.5, we would have a half. So it's really close. It's just not exact. And the same thing would happen with a die. If you just rolled the die several times and recorded what it landed on, it should have a probability of 1/6 for each one of the numbers. But if you really roll a die just a couple of times, maybe 20, 30 times, you would find that empirically it doesn't work out all the time. Now, if I flip the coin multiple times, many, many times, more than just 20, 200 and then 2,000. What happens is the probability of the event would get closer to a half. And this is one of the laws of large numbers. So empirically, we could do the experiment many, many, many times, and eventually we'll end up at the theoretical probability. It's just you have to do it a lot so that the number on the top and the bottom start balancing out towards a half. And that's one of the cool things about probability. Even though empirically this isn't exactly a half, if we did more trials, it would get really, really close to being the theoretical probability. In the end, which is kind of neat if you think about it. So the theory and the empirical do have a common ground.